In Module 4, we're going to talk about rational functions and radical functions. And we're going to start with rational functions. And let's go ahead and review by defining a rational function. So a rational function is defined as a function that is the ratio of two polynomials. And just like regular fractions, we cannot divide by 0. So that leads us into the domain of a rational function. So because we cannot divide by 0 in a rational function, its domain is the values for which the denominator equals 0 have to be excluded. So for the domain of a rational function, we find when its denominator is 0 and we exclude those specific values from the domain of our rational function. So now let's do some example. Let's find the domain of our rational expression. So we have f of x equals x over x squared minus 25. So we need to find when the denominator is going to equal 0. So we need to find when x squared minus 25 equals 0 and exclude those values from our domain. Well, x squared minus 25 is a difference of squares, and it factors as x minus 5 times x plus 5. Which means the values that make our denominator 0 are going to be 5 and negative 5. So our domain is going to be x cannot equal 5 and negative 5. Those values are excluded. Any other value will work in our function. Our second example is g of x equals x plus 2 over x cubed minus 5x squared plus 4x. So we have to find when our denominator equals 0. So I want to find when x cubed minus 5x squared plus 4x equals 0. But notice every term has a variable, so the first thing I'm going to do is factor out the x. So we factor out the x, so we end up with x squared minus 5x plus 4. So now I want to factor x squared minus 5x plus 4. So when I do that, we get x minus 4 x plus 1. So this time I'm looking for when x equals 0, x minus 4 equals 0, and x minus 1 equals 0. So there are going to be 3 values we exclude from our domain. So our domain is x cannot equal 0, which comes from the x, 1, or 4. Those 3 values are excluded from our domain. Okay. Now we're going to talk about what a rational function in lowest terms. So a rational function in lowest terms, what we mean by that is we want to factor the numerator and denominator of our rational function, and then cancel any common factors. So when we talk about the lowest terms, it's when we factor our numerator and denominator and cancel any common factors that appear. And when that happens, we get a rational function in its lowest terms. So we're going to put our rational functions in lowest terms, and we're also going to state the domain. So looking at our first function, f of x equals x squared minus 2x minus 8 over 2x squared plus 2x minus 40. So we want to start by factoring the numerator and the denominator. So if I look at my numerator, x squared minus 2x minus 8, I'm looking for the numbers that multiply to negative 8 but add to negative 2. So when we factor, we get x minus 4, and then x plus 2. And in my denominator, before I start factoring, I notice 2x squared, 2x, and 40 are all divisible by 2. So what I'm going to do is I'm going to factor out that 2 first. So when I factor out the 2, we end up with x squared plus x minus 20. Now we're going to factor the quadratic that's inside our parentheses. So our numerator is staying the same. In our denominator, so now we're looking for the numbers that multiply to negative 20 but add to positive 1. And that's going to be 5 and negative 4. So we end up with x plus 5, x minus 4. Now before we find any common factors that cancel, we want to go ahead and state the domain now. So if I look, my domain, I want to find the values that make my denominator 0. So I have x plus 5 and x minus 4. So my domain, my values of x that I'm going to exclude, so x cannot equal negative 5 or 4. Now we can go ahead and cancel out common factors. So we see that in the numerator and denominator we have x minus 4. So we're going to cancel those out. So my final answer, my polynomial in my rational function, I should say, in lowest terms, f of x is going to be x plus 2 in the numerator, and then 2 times x plus 5 in the denominator. Our last example is f of x equals x plus 2 times x plus 9 all over x plus 2 times x minus 3 times x plus 4 times x minus 5 times x minus 7. So let's go ahead and start with the domain. Since my numerator and denominator are already factored, I don't have to factor them. So I can go ahead and list the values that are going to make my denominator 0. So I'm going to list them from my negative numbers together and then my positive. So I go negative 2 and negative 4. And then we have 3, 5, and 7. So these are the values that x cannot equal in my domain. Now we can go ahead and cancel out anything that appears in the numerator and denominator. And the only thing that appears in both places is x plus 2. So we can go ahead and cancel those out. So now my rational function in lowest terms, f of x is going to equal x plus 9 in the numerator, and then the denominator is going to be x minus 3 x plus 4, x minus 5, x minus 7. And that would be my rational function in lowest terms.